We're given the function y equals quantity x minus 2 squared, or if you prefer, y equals f of x equals quantity x minus 2 squared. First thing we want to do is construct a graph of this function. The first thing we did, and we started by constructing the graph of y equals x squared, the white graph here, with points 1, 1, 2, 4, 1 half, 1 fourth, 0, 0. So we construct this part of the function. Then we realize that this is this function isn't one to say it's an even function, but we haven't used that terminology yet. This function is symmetric with respect to the y-axis because if we replace x by negative x, it doesn't change. If we square negative x, we still get x squared, so that we reflect the graph in the first quadrant across the y-axis to get the graph over here. Now we don't really need to do that because it's easy to see that negative 1, 1 and negative 2, 4 are going to be points on the graph, and that is going to lead us to a symmetric graph. But we want to use valid and the most efficient graphing techniques. And the most efficient technique is to look for symmetries. And translations and so forth. So, and that's where we're going to go. So from y equals x squared, y equals the quantity x minus 2 squared is going to be shifted 2 units to the right. So every point moved 2 units to the right, and we get this green graph. And again, the reasons for that, in order to get, for example, y equals 0, for y equals x squared, x could be 0. What do you need in order to get 0 for y equals quantity x minus 2 squared? Well, x has to be 2. X has to be 2 units bigger here to give you the same value it would here. In other words, in order for x minus 2 squared to give you the same result as x squared, you're going to have to use an x that's 2 units bigger here than you will here. Okay. Now, just looking at it in terms of, excuse me, the operations you would use on a y equals x squared graph. We start with y equals x squared. We shift it 2 units to the right. Gives us the graph of y equals quantity x minus 2 squared. Okay, then we ask some questions. We ask about the distance from the origin to various points. Okay, well, the first point is the x equals 3 point. Where's the x equals 3 point on the graph of y equals quantity x minus 2 squared? Well, if x equals 3, 3 minus 2 quantity squared is 1 squared. That's 1. So the point is 3, 1, and 3, 1 does clearly lie on the graph of this x minus 2 squared function as we pictured it. Here's 3, here's y equals 1. So here's the point 3, 1. Now we're asked about the distance from the origin to this point. And I sketched this straight line here, and actually I kind of sketched a triangle, but I want to draw a little better sketch, so I'm going to do that and then I'll come back. Okay, as I say, we have the point 3, 1, the origin. Distance from 3, 1 to the origin is the length of this line segment, and that's part of the fundamental triangle. And I've drawn the fundamental triangle a little more clearly here because it's kind of obscured by all the other things we've done with this graph. But it's clear that the dimensions of this triangle are 3 in this direction, 1 in this direction, so that along the hypotenuse we have the square root of 3 squared plus 1 squared. And that's what we say here. Okay, the distance from the origin to this point is the hypotenuse of a right triangle with legs 3 minus 0 equals 3 and 1 minus 0 equals 1. So the distance is square root of 3 squared plus 1 squared, which is the square root of 10. Now, same question was asked for the point, for the x equals 5 point. Well, the x equals 5 point, x value is going to be 5. The x coordinate is going to be 5. That's going to be out here. It's going to be probably up here near the top of the board, and maybe even off the board, probably right about here. I didn't draw that point, would have cluttered the picture up too much, but the reasoning is almost identical. Distance from the origin is ... same reasoning, draw that point, draw the line, draw your fundamental triangle. And it should be clear that we're going to get 5 squared plus 9 squared under the square root. So we're going to have square root of 106 if I did my arithmetic correctly. Okay? So that should be pretty obvious. You should draw that. You should, sketch it and convince yourself that those are the legs of the right triangle whose hypotenuse goes from the origin to the point 5,9. Okay, now we ask about the x equals a point, and here's where people started to hesitate a little bit and weren't sure what to do. But you just do what it says. If x equals a, then what does y equal? Well, if x equals a, we're going to have to put a in where x is. And we're going to get a minus 2 quantity squared, and that's going to be our y coordinate. So the x equals a point has coordinates a minus 2 quantity squared. Okay, the legs of the fundamental triangle, well, I've actually drawn that one in here at risk of cluttering up the picture too much. Here's the point that I call a minus 2 quantity squared, and probably would have been good for me to close off my parentheses around the a minus 2. So we have a quantity a minus 2, and I got the square in the wrong place. I'm going to go off camera for a second and fix that. Okay, now it reads correct. So here is this point depicted on the graph for a typical value of a. And we draw this segment from here to here just as we did over there and just as you would have done in drawing this out. And we draw the fundamental triangle. I chose to draw it this way so as not to obliterate everything we have down here. And this leg of the triangle then has length a, because of course the x coordinate is a, so a would be here, and from the origin out to this point the distance is a. And this side is going to be quantity a minus 2 squared. Then it's very straightforward to write down the distance. This squared plus this squared, square root of. So here it is, and here's an expansion. Now the a squared would combine with the 24a squared to give you 25a squared. And I did all this in my head, and there were a couple of operations there, and my head ain't working that well today. So check me on that, make sure that really is the way the a minus 2 quantity squared expands. That would be a minus 2 quantity to the fourth, and I just used the binomial coefficients, which here are 1, 4, 6, 4, 1. 1, 4, 6, 4, 1, and we're doing 2 powers of 2. I think I got it right, but again, double check me. Plenty of places I could have made a mistake. Okay, so that's the expression. Now, the other question was, well, what about the xy point on the graph? Well, xy could be any point, but it has to be on the graph. Now, the distance from the origin to xy is x squared plus y squared, square root of x squared plus y squared, and that's very straightforward. I haven't drawn that. But if you put xy out here anywhere, draw the triangle and so forth, that's clearly what you're going to get. You're going to get x this way, y this way, and there you have it. However, of course, this point has to be on the graph so that y has to be equal to x minus 2 quantity squared. So y equals x minus 2 quantity squared, so the distance is x squared, just as before, plus y squared, but now y squared is quantity x minus 2 squared squared. And then I just got an etc. there. Notice that this is exactly the same as this, except here we've got an a, where here we've got an x. So if you replace all the a's here by x's and simplify it, you should get the same thing that we're going to get here. So there's the general formula for the distance from the origin to a point on the y equal x minus 2 quantity squared graph.